Okay, so today we are looking at linear programming, and the first thing I want you guys to do is read along with me the definition of what linear programming is. Okay, it is a method for solving problems in which a particular quantity that must be maximized or minimized is limited by other factors. Now, a lot of you are always asking me, when am I going to use this in life? I guarantee you, you will use this in your life without knowing it. I can think of one example that all of us here in the United States have to do every year. What is that? Taxes. Taxes. There's two guarantees in life, death and taxes, right? Okay? So, all right. It's a famous quote. It's not from me.
Death and taxes.
Okay, so that being said, you want to minimize how many taxes you pay in. Now, you may not realize that you're doing this, but whenever you fill out those forms, you're actually doing some form of linear programming to minimize your taxes. Okay? Using TurboTax does that for you. Finding all your deductions, finding all your constraints. Okay? Or if you hire somebody else to do it for you, yes.
Did TurboTax pay you to say that?
Absolutely not. I'm just saying that as an example.
You should try to get them paid.
Okay, so going on, objective function. An objective function is an algebraic expression in two or more variables that describes a quantity that must be maximized or minimized. Okay? So, an example of an objective function. Hold on a second. So, an objective function, here is an example of finding an objective function. A company manufactures bookshelves and desks for computers. Let X represent the number of bookshelves manufactured daily and Y the number of desks. The company's profits are $25 per bookshelf and $55 per desk. Write the objective function that describes the total daily profit. Okay? Z is your profit in this case. So how would you write the equation for Z?
You can do this. Alright. Can I do it?
Yep.
Alright. Z equals X is how many bookshelves are sold.
Yep.
And Y is okay. So it's X times 25.
Yep. 25x plus
55Y.
55y. Good. Okay? That is your objective function. That's what you're wanting to maximize, the profit. Okay? Now that we know our objective function, we got to find our constraints on the function. Okay? So that's the next part. A constraint is a restriction that is placed on the resources. Each constraint is expressed as a linear inequality. Several constraints together form a system of linear inequalities. Okay? We have two of them on this case, or three actually. To maintain a high quality, the company above should not manufacture more than 80 bookshelves and desks per day.
So combine.
So I'm going to have X plus Y. Yep. That's our first constraint. Our second constraint is this. To meet customer demand, the company must manufacture between 30 and 80 bookshelves per day. So that means I have a low number of 30 as my lower limit. My upper limit is 80 for my bookshelves. The next part says, furthermore, the company must manufacture at least 10 and no more than 30 desks a day. So 10 is my lower limit of desks. 30 is my upper limit of desks. I want you guys to recall that our objective function was Z equals 25x plus 55y. Our constraints were x plus y is less than or equal to 80. It was also 30 less than or equal to x less than or equal to 80, and 10 less than, oops, 10 less than or equal to y less than or equal to 30.
Where are we writing this?
Just at the top of the page.
There is no.
Or somewhere on the side of the page then. That's fine. Okay? All right. So, recall that. Now, we need to graph our 3 constraints. Not the objective function. The 3 constraints are what we are graphing. Okay? So the first one, x plus y is less than or equal to 80. The easiest way to graph that one is by intercept. So if I cover up my y, what's my x value going to be? 80. And if I cover up my x, my y value is also 80. Okay? So I'm going to count these out by up to 80. I'm going to start here at, actually I'm going to make my lower value is supposed to be 30. I'm going to start at 30 on the bottom. 30, 40, 50.
How are you starting? Where's the rest of that though?
I'm starting because my lower limit was 30 here on the x values, so I'm just starting at this point right here.
You have to start a graph at 0 or mark off that you're starting at 30 though.
Then fine, mark it off like that.
I'm sorry, I've had teachers yell at me for 40 minutes about that before.
Okay. All right, I'm going to do the same thing with the y's. So what's my minimum of my y's? 10. So I'll start off at 10. Okay? 10, 20, 30, 40, 50, 60, 70, and then 80.
You don't have to mark it off on that one because you're going by tens.
Okay? So, now, before, remember we said our x value and our y value for our intercepts is at 80 and 80. So here's my 80, and here's my 80 here. Is that going to be a solid line or a dotted line? Solid. So I'm going to connect my lines here, like that. Okay, so we've graphed our first line, but we need to put in our constraint, our shading, okay? So our shading on this part, if I put 0, 0 in for x and y, is 0 less than 80? Yes, so I'm going to shade everything in this section. Okay? Huh? I put in 0 and 0 for x and y to find that. Now, I'm going to also need to graph, I just graphed this one right here. I need to graph these two. Okay, so x is greater than 30. That's going to be a line that is going from 30 and it's vertical, going straight up. And x is less than 80. That's also a line that's vertical, going straight up. Okay? My y values are between 10 and 30. So I'm going to graph above 10 and below 30. Whoops, I didn't exactly graph that one straight, but okay. So what area am I going to shade for those? Remember, I have to be between the two vertical lines and between the two horizontal lines. So my area right in here, that's below that the slanted line, and between all four of those other lines is right here. So I found x and x between 30 and 80. That's between these two vertical lines. Between the two horizontal lines. So, and also I had to be lower than this. Okay? So this area right here is called the feasible region. Okay? So we found our feasible region. Our next step on this would be to find our points of maximum and minimum. So I'm going to put a dot at every corner of that region here on the graph. Okay? Our first corner is at what? 30-10. This corner is at what? 30-30. This one over here, it's kind of hard to see. We're not exactly sure. Okay, it looks like 70-10 possibly. And this one's possibly, I'm not sure either. So what we need to do, and we can't just base it on sight in this case because the scale is different from the vertical scale, okay? We need to actually find those. So I'm going to base off of y equals 10 to find what x is here. I don't know what it is. I'm going to put that into my original constraint. So y equals 10. So x plus 10 is less than or equal to 80. I'm solving by substitution. Okay, so I'm first putting this into it. Okay? So x is what in this case? 70. So this point right here is 70, 10. I'm going to use substitution again for this, but what's my y value going to be here? 30. So x plus 30 is less than or equal to 80. So what's x in this case? 50. See now how I couldn't really use the scale? It looks like it's over at by 60, so I'm glad I didn't use just how the graph looks. Okay? So it is 50, 30 right there. Now we're going to take those 4 points and find out what is our maximum profit at those 4 points and figure out how many shelves and how many desks we need to make. So I'm going to test each of these. I'm going to erase this part for now. Okay, so we remember that z equals 25 times x plus 55 times y, right? And if I'm going to test the point 30, 10, I'm going to put in 30 for x and 10 for y. When you put that into your calculator, I think you get 1300. So, yeah, you get $1,300 or $1,300. Okay? Now, if I do the same thing for 30, 30. I'm going to test that one now. So z equals 25 times 30 plus 55 times 30. Ooh, I did that wrong. You get 2,400. Now we're going to test for 50, 30. So you guys see what I'm doing? Okay. So 25 times 30 plus 55. Oops, it's times 50, right? Times 50 plus 55 times 30. You get 2,900. 2,900. And then the last point we need to check is at 70, 10. So 25 times 70 plus 55 times 10. And that's at 2,300. So what is our max profit in this case? Yeah, it's this one right here. So, how many shelves and how many desks do we want to make? 50 shelves and 30 desks. Okay, to get our maximum profit. All right?